Now let's start with the session. Okay. So we'll be learning the association rules. I'll just take a review again. Okay. Now am I audible? Please check. Am I audible? So advanced analytical theory and methods we'll be discussing, and in that we are learning about the association rules. So association rules, a priori algorithm, support confidence, leverage, all this will be the main agenda for today's discussion. So the first association rules, as I mentioned, it is a descriptive method which is used for which describes the relationship between the different objects that exist in the data set. Okay, it is nothing like your k means or k nearest neighbor and all other algorithm which is used for prediction or used for classification purpose. The previous technique that we discussed, k means, it was like clustering the data and classifying the data into the different assigned clusters. Okay. Now here you will be learning that how the relationship between or how the two close related products or the items are associated with each other. Many a times in our day-to-day operations, we are not able to observe them. Okay. So as I had given you the example of retail shop. In retail shop, there are thousands of transactions which are happening. Different types of inventories are being generated. But at the back end, what has to be done? They need to do the analytics. So while doing this analytics, they apply one of the technique like association. They find out what is the dependency of one product on the other, or how the two products or how three or how multiple products are linked with each other. Okay. So this helps the organization to maintain the stock, to maintain or take the necessary decisions. Okay. So from the existing data set, how the frequent item sets are managed. So they are commonly used for mining the transactions in databases. So like finding which product is similar to the other product, what is the tendency of buying, what is the tendency of buying a product, or what is the pattern or what is the behavior of the customer after buying a product X, what they prefer to, okay, and all other stuff. Okay. So here in the example, you can find out that when someone purchases the milk or sorry, cereals, so 90% of the customers are buying the milk. This is something discovery they found out, means it has been discovered from the transactions. If someone buys the bread, 40% of the people purchase the milk. Of course, there is a relationship between the bread and the milk. And if someone buys the milk, they also 23% of the customers are buying the cereal. Now, this example is related to the transactions which are observed as shown in the diagram. Similarly, in different scenarios, there are different types of products which are associated with each other. And just to understand their dependency or their association, we need to apply such association rules. Okay. So let's see now here. Each of the uncovered rules is in the form X implies Y. The meaning is like when the item X is observed, item Y is also observed. So in this case, the left hand side of the rule X and the right hand side of the rule is Y. So an item set containing K items is called a K item set. Item 1, item 2, all these K item sets are used to denote a K item set. All these are the subsets, item 1, item 2. Again, I would like to give you the example. In a retail shop, when someone purchases the vegetable oil, he may also buy the other groceries. So what is the frequency of someone buying the vegetable oil and other groceries and then buying the toothpaste? Or if someone buys the toothpaste, what is the other dependency? So the first product that comes out in the list and accordingly the relationship. And based on that, all these retail shops, they come out with the various strategies where they enhance their business. They provide the best of the services that can be offered to the customer, the best of the prices, and whatever the win-win situation that can be introduced from the management level. Okay. For example, if 60% of the transactions contains the bread and jam, in the existing database, the 60% of all transactions will contain bread or jam either. In other words, when the support of bread and jam is 0.6, the support of bread or jam is at least 0.6. That means out of 100 transactions, 60 transactions are being observed that bread and jam is there. 60%. Not necessarily both are there. Maybe the bread, maybe the jam, but maybe both also. Got it? Like that. So just in the diagram, you can find out the transactions are there. A, B, C, D. Then here, bread, B and C. See the relationship now. A is having the relationship A, B, A, C, A, D. Then B is having the relationship B, C, B, D. C is having C, D. So like this, the combination of these transactions are there. Now again, we are going to the next support value. We are taking the combinations of now A, B, C, A, B, D, B, C, D. Okay. And ACD. ACD is already taken. And now next, what is the frequency of buying all the four products? A, B, C, D. Hope now you understood this diagram. Yes, please reply. Now, the frequent pattern analysis. Finding the frequent pattern analysis among the existing data set. So we are just comparing in the data set what are the items, the listed items. What is the frequency of buying item 1 and item 2, item 1 and item 3, item 1 and item 4, item 1 and 2 together, or item 2 and 3 together, or 1, 2, 3 together, or 1, 2, 3, 4 together. Okay. Take an example like there do exist again some regularities or inherent regularities that actually appears in the data. Or the example as shown in the slide also. What products were often purchased together, whether beer and diapers? What are the subsequent purchases after buying a PC? Like I had given you the example. What are the subsequent purchases after buying a car? So of course, one goes for buying the accessories. What kinds of DNA are sensitive to this new drug? So whenever any drug research is going on, so after understanding the structure of any of the microorganism, so they try to apply, they try to they do select the necessary antibodies and accordingly they apply. Can we automatically classify web documents? Okay. So all these are the different problems which motivates one to find out the frequency in the data sets. There is the market data analysis, or sorry, the basket data analysis, which is one of the popular applications, part of data mining again. Cross marketing. Now, what is this cross marketing? You might have observed, like recently the Wipro means used to come out that see what are the products which Wipro is having. Basically, they have the vegetable oil, they have the ghee, okay, they have the ghee, then they do have the lights, okay, Even the Santur soap you can find, it belongs to the Wipro. Now, the sale for the Santur soap is very limited in the market, although the ad is very popular. But at the same time, just to sell the product, or they are using that product for branding purpose. So what they did, they started cross selling. If you'll buy a tube, then they were offering the Santur free after buying the tube. Means tube means the lights. So if you're purchasing the Wipro bulbs or tubes, light tubes, so you will be getting the Santur soap free. So this is called cross marketing. So there is no relationship between the tube and the product, means the soap, isn't it? But it is called as the cross marketing. Hope you understood this cross marketing. So the tools are there which are used to identify that what sort of cross marketing can be there. Now you might have seen again, after buying some vehicle, you will get the gold coin. Okay. Now gold coin and the vehicle, there is no relationship. When you purchase the flat, then again you get the car. Now flat and car, okay. So it becomes the kind of luxuries. So the builder is offering, or after buying so and so, booking a flat, you will get the LED television or refrigerator or air condition. So like this, the cross marketing is taking place. Okay. There is again the sale campaign analysis. Then there are weblog analysis. Now the weblogs are there. What is the frequency of search, or what is the pattern of searching on the Google? What you basically prefer to search on the Google. Okay. Not only Google, or on any of the search engine. And accordingly, your search engine learns about your pattern of searching. Hope you are getting it. So those patterns are being recorded, because anyway, nowadays you have been, while searching, we are by default log into our search engine, or your mails are been stored. You can find your profile. So your profile based searching is happening. And then again, wherever you go, or whatever agreement the Google is having, the Google is having agreement with Amazon, with Facebook, because using their email IDs, you can log into those respective services. So the moment you enter in all these different portals, you start receiving what? The advertisements, promotions. Okay. So you can find the promotions, and you just have a feel that I was just searching on the Google, and just now I am finding all this product everywhere. So it makes the impact. So such type of analytics, or we can say the data science, which is used, and you become one of the customers. So this is the frequency of means frequent pattern analysis. Similarly, there is again another DNA sequence analysis, which is widely used by the pharmacist or the pharmacy industries. Okay. So these industries are doing the research and trying to find out the medicines, the new medicines on the different diseases. Okay. Any questions still here? Yes. Fine. Now, why is this frequent pattern mining important? See, now before coming, or in order to find out the relationship between the objects, any of the two objects, we cannot hypothetically link. Okay. But from our own nature of purchasing, or our own purchase pattern, like if I go to the milk dairy, if I'm buying a milk, of course the dairyman is also, see, he need to take the decision that what type of items I should sell. The dairyman cannot sell all the items which the general stores is selling, or which the pharmacist is selling. Am I right? So he need to select the suitable products which appears in the pattern, in a selected pattern. So in order to make that decision, one need to understand the frequency of these objects, and hence this pattern mining, or finding the frequency in the pattern mining, is important. So what it does, it discloses an intrinsic and important property of the data sets. It forms the foundation for many essential data mining tasks like association, correlation, and causality analysis. Then it also deals with the sequential structural patterns. The pattern analysis is the spatio-temporal, multimedia, time series analysis, and stream data. There exists again the classification that contains the associative classification. Now, what this associative classification is, if someone is just playing a cricket, then he may also play football. If someone is playing the football, he may also be a rugby player. See, associative. If someone is playing lawn tennis, he may also be the table tennis player. So there are many cricketers who are also the good football players. There are some football players who, or they are also the good hockey players. So multi-sports talent, we say. Data warehousing, the iceberg cube and cube gradient, all these are some applications. Semantic data compression. Okay. Now, what this diagrams appeals here? What it is appealing here? So there is a market analyst. Like I had given you the example of the dairyman. So he is just searching for the items which are frequently purchased together by his customers. So customer one is buying the milk, bread, and cereal. He's just observing this customer baskets, shopping baskets. Customer two is buying milk, bread, sugar, eggs. Sorry. Customer three is again buying milk, bread, butter. So maximum customers are buying all these different products. So somewhere you will find whether milk is common, bread is there, or sugar is there, or eggs. Out of these four products, at least in each basket, you can find one product that is appealing. So this is what finding the frequency. So let's see now technically how actually these things happens. Okay. Now, these are the transaction IDs you can find. So I'd like to just mention it. This is also called as a priori analysis. Okay. So what happens? This is the data set which containing all these different transaction IDs. A, B, C, D, all these are the items. Those are existing or appearing in this different data set. In each transaction, there is a frequency of some item. So in transaction 10, transaction ID 10, you can find out the items what are A, B, and D. In transaction ID 20, the items what are A, C, D. In 30, you can find E, D, E. In 40, you can find B, E, F. 50, there is a B, C, D, E, F. So the item set X, which equals X1 to Xk. Okay. So all these A, B, C, D, all these are the X. A is X1, B is X2, C is X3, or all these are the different items. Hope it is clear now. Fine. Now to find all the rules, that if X is purchased, what it implies, what is the implication on the Y? With the minimum support and confidence. So first of all, try to understand what exactly support is. You can make a note at your end. Support is denoted by the S. It is the probability that a transaction contains X union Y. Then confidence, C. It is the conditional probability that a transaction having X also contains Y. Hope you got it. Now here in this diagram, you can find out the Venn diagram. See the yellow color, it represents the customer who buys the beer. The blue color, you can find a customer who buys the diaper. And there is an intersection here, you can find that these are the customers who are buying both. Not intersection, or you can see just the common area where the customer is buying both the products. The customer who buys beer as well as the diaper. Okay. So now confidence, C. It is a conditional probability that a transaction having X also contains the Y. Now this is the probability. Okay. It is not certainty. Okay. Now let the minimum support value is 50%. Minimum confidence value is 50%. the frequency of pattern as given. Now see, how many times A is occurring in the data set? Can you just tell me? How many times A is occurring in all this? In how many transactions A has occurred? Count. See, these are the 5 transactions. Just answer how many times A has occurred. Exactly 3 times. So see the value of A, you can find 3. How many times B has occurred? In how many transactions B has occurred? Again 3. In how many transactions B you can find 3. In how many transactions D is occurring? In how many transactions D is occurring? 4. In how many transactions E is occurring? Tell me the number of transactions containing E. 3 exactly. And the number of transactions containing F. 2. Okay. And now the combinations of AD we are checking. What is the combination of AD? If A is there, D is also there. You can find total 3 transactions. Hope you got it. Fine. Exactly. Now let's see the association rules. A implies D. So that means out of this 5 transactions, 3 times A is purchased. 3 by 5 means what is the percentage level? 3 by 5 means what is the percentage level? 60%. Right? And D is what? Almost 100%. Okay? When A is purchased, total how many transactions are there? When A and D both are there, the frequency of A is total 60%. But what is the frequency if A is purchased then D is also purchased? 100%. Okay? Vice versa. If D is there, what is the frequency? How many times D has occurred? D has occurred almost 75%. 4 transactions out of 5. But what is the frequency if D is purchased and A is also purchased? So total, it is again the 60%. Understood now? Okay. Shall I go for the next part? Okay. Now, the close patterns and max patterns. So a long pattern contains a combinatorial number of sub patterns. For example, A1 to A100 contains like 100 raised to 100 square up to 100 raised to 100, which equals 2 raised to 100 minus 1. This is what the equation which is given, which again contains 1.27 into 10 raised to 30 sub patterns. Now mine close patterns and max patterns instead. So an atom X is close if X is frequent and there is no super pattern where Y is the subset of X with the same support as X. An atom X is a max pattern if X is frequent and there exists no frequent super pattern which contains Y subset of X. Now an atom X is a max pattern if X is frequent and there exists no frequent super pattern which contains where the Y is the subset of X. Sorry, superset of the X, you can say. Now close pattern is a lossless compression of frequency patterns, that is reducing the number of patterns and rules. Here you can find like what is the set of closed atoms. Let's say the example. There are transactions A1 to A100 and other transactions like A1 to A50. The minimum support value is 1. That means one transaction in one. Now what is the set of closed atom set? A1 to A100, 1. Now again in A1 to A100, A1 to A50 are repeated. So that's why it is a 2. What is the set of max pattern? So A1 to A100 is 1. What is the set of all patterns? That is the factorial that we need to combine or calculate in the combination. Okay. Now coming towards the next part. the scalable methods for mining the frequent patterns. So here you can find the downward closure property of the frequent pattern. Like any subset of frequent atom set must be frequent. Okay. So this rule you need to understand. For example, if the customer or if someone buys the beer, diaper and nuts, and if it is a frequent, so beer and diaper are the frequent patterns. That is, every transaction having beer, diaper, nuts also contains beer and diaper. The scalable mining methods, like three major approaches, which contains the a priori, which also contains the frequent pattern growth and the vertical data format. Okay. So let's see the first one, a priori algorithm. Okay. Now already you have been introduced with that particular method, what exactly this a priori is. It is a candidate generation and test approach. Okay. So in a priori pruning principle, if there is any atom set which is infrequent, so its superset should not be generated or tested. The method, like initially scan database once to get the frequent one atom set, generate length k plus 1 candidate atom sets from length k frequent atom sets, test the candidates against the database, terminate when no frequent or candidate set can be generated. So again, I will revise the method. See what is there. Initially, you have to scan the entire database. You need to just check what is the frequency. Okay. What is the frequency of all the transactions? Means in what manner all these transactions are occurring. Okay. Then later you have to just check. Yes, then later you need to simply check that what is the k plus 1, means the next frequent atom. Okay. So like this, the combinations you are going to check it. Let's see graphically now how actually it happens. What you are observing in the first, there are number of transactions, means the database is given TDB, the database with transactions. First scan contains the frequency of each individual atom in the entire data set. This is what the first scan you need to do. So what happens in the first scan? A, how many times it has occurred, B, how many times it has occurred, C, D, E. So what is the frequency of A? Yes, what is the frequency of A? Can you please answer? How many times A is occurring in the data set? What is the frequency of A? 2. What is the frequency of B? Fast. In how many transactions B is occurring? C is occurring, D is occurring in 1, fine, E is occurring 3. Now let's see the next combination. Okay, so this is the first scan. Now what we are going to do, the items with the minimum frequency has to be eliminated. Okay, items with the minimum frequency has to be eliminated. So which particular atom is having the less frequency? Yes, which atom is having the less frequency? D. So in the next new data set which is generated now, K plus 1. Earlier one was the K, now next is the K plus 1. So we call it now L1. So now D is eliminated and now we are having A, B, C, E. Okay. Now we are going to compare the combinations AB, AC, AE. Okay. See now it is coming from right to left. Please check it now. It is coming from right to left now. So generate all these combinations AB, AC, AE, then BC, BE, and then CE. All these are the possible combinations. Hope you got it. Now check in the database that when A and B, in how many transactions both are there, A and B? How many transactions are there where A and B both occurs? Only one. This is the second scan now. Okay. So we have generated the candidate list 2, C2. Okay. And now we are scanning them. What is the frequency that A, C both are occurring? In how many transactions both A, C are occurring? Transaction number 10 and transaction number 30 you can find. Okay. So there are total 2 transactions. In how many transactions AE is occurring? AE, occurrence of AE 1. In how many transactions BC is occurring? Fine. BE, in how many transactions BE is occurring? 3. And the frequency of CE? Frequency of CE 2. Till here it is clear? Fine. Now remove or eliminate the item sets with the minimum support value. Eliminate the items with the minimum support value. Now which are they? AB and AE. So we are going to eliminate AB and AE. Right? So they are containing just the one transactions. Fine. Now let's have a new candidate list. So AC, BC, BE, CE. Now let's do the combinations. We'll have ABC, BCE, only this much. Now how many transactions are there? ABC is occurring only one. Assuming, okay, AC is having 1. You can find out. ACE and BCE, only these 2 combinations are possible. So in how many transactions ACE is occurring? Only in 1. And BCE is occurring in, BC is occurring in 20 as well as in 30. I hope you got it. Have you understood this? Okay. ACE and BCE. So now the support value is what? 2. Okay. So you can find out in the given data set, in this entire data set, the frequency of BCE is more. So there is a strong association rule that BCE, at least B or E will be there, or B or C will be there, or BCE will be there, or BE will be there. Any combination. So like this, the inferences you can draw out of this particular database. Any questions? This is what exactly the a priori algorithm is. Okay. Now you can just see the steps. What is the first step? You have the CK. Those are the candidate item set of size K. LK. Those are the frequent item set of size K. L1 is what? Frequent items. K is what? The number of iterations that we are going to apply. So now what is happening? L1 frequent item sets. So that is what the first we are finding. A, C, E, all those we are listing. We are finding their occurrence, frequency of getting. Then again, you are checking for each transaction T in database, do what? Increment the count of all the candidates. So we are doing that increment. Okay. And after doing that, again, we are generating the new data set coming towards the upper loop now. Next. So L1 is there, L2 is there. So you can just find out, see L1, L2 as given in the data set. And at the same time, C1, C2. So these 2 loops are assigned for each L1 as well as LN as well as for C. Whether you got it? Yes. And finally, it returns the combination union of. Okay. So C union L. This you can find. So this is the algorithm for a priori. Any questions here? Yes. Yes. Any questions? Fine. Now, these are some details like how to generate the candidate. So step 1 is like self joining is there. Step 2 is pruning. How to count the support of candidates? Example is given and already you have learned. So apply the self joining. See the combinations as given in the database. Okay. C is missing actually. Sorry. It is a union of LK, not a C union. Okay. It is only the union of L. Recursively, it is calling it. The pruning ACDE is removed because AD is not in the L3. Okay. So with the minimum support, the values will be pruned. And finally, it has discovered that the patterns A, B, C, D are frequent. Okay. How to generate the candidates? Again, the self joining. Take an example using the query like insert into the CK candidates. That select P items 1, P dot item 2 up to Q dot item K minus 1. From LK minus 1 of P and LK minus 1 of Q, where P dot item 1 equals Q dot item 1, P dot item K minus 2 equals Q dot item K minus 2, and so on. This is the self-joining process. Step 2, pruning. Pruning means eliminating the item sets with the less frequency. Okay, that is the pruning. Now, how to count the support of candidates? So, first of all, why counting supports of candidates a problem? Because the total number of candidates can be very huge. See, right now we are just done with the 4 to 5 transactions. Imagine the transactions which are happening in any of the retail shop. It may be the Walmart or D-Mart or Big Bazaar or whatever. Okay, thousands of transactions at one particular outlet. And when they are integrating the data and and trying to do the processing on the centralized data, so that particular figure might be different. Okay,